And welcome back to OneClass. Again, my name is Joey. I'm going to be your math teacher for this session. Just a little bit about OneClass and a little bit about us before we start. Again, here at OneClass, I know amidst the COVID-19 school closures, we're very, very valuable to kind of transition, pivot very, very, very quickly to adapting into kind of online teaching and online resources. So we're able to share kind of the resources we have at OneClass with you all through these live streams and through these YouTube videos as well. So we're very fortunate at OneClass to do that and to have to work alongside some great teachers that are doing the same thing. Again, my name is Joey. I'm currently an Ontario school educator. My subjects of interest are chemistry and math as well. And what we're doing here at OneClass and what we're doing through these sessions here, or these live streams, is that we are verifying some frequently asked problems in both the secondary school level and as well as the university and college level in subjects such as math and in chemistry as well. So what we're doing here is that we, in this hour, we're going to go through some frequently asked problems. Specifically, with these problems here, we have they're going to be in the not linear algebra, but algebra 1, pre-algebra and geometry questions. So we have questions regarding those problems there. So without further ado, let's get started on today's problems. I have about 11 for us today. I will be able to kind of work through them as well. So number 1 is asking, I'm given this kind of equation here or formula here, and we want to solve it or simplify it. I'm pretty sure it's a simplified question, so let's see what we're going to get here. So this is, I'm going to write this down. So I have 8 plus, and then I have a bracket here. This is 22x. And then another bracket here, 15, and then another bracket here, 14 times 2, and then bracket, and then a square bracket here. So we have all these guys here, and what we want to do is we want to figure out what the simplified equation here is first. So I believe that this is a 22x here, and this is a multiplication sign. If someone, it depends on what this is here. I believe this one's a multiplication sign, and this one here is the variable. So this here is just to verify this is a multiplication symbol, and this x would be a variable here. Just so that we're not confused here. So basically what we're going to do is we're going to follow this concept of BEDMAS or PEDMAS if you're from America here. So basically, if we want to review PEDMAS here, we have first is our parenthesis, and then it's our exponents, and then it's divide, multiply, add, and then subtract, right? So this is the order of operations. And in this case here, we have a lot of brackets here. When we have a lot of brackets here, we care about working it as like kind of visualizing it as kind of an onion. We want to peel it from the inside and make sure we come out and get it to the outside here. So you can think of it as peeling some sort of onion is how I kind of visualize it. So I'm working from the inside here, and then I'm going to slowly work my way out. So let's work from the inside here. So again, I only have parentheses here, right? So I'm going to solve the inside parenthesis first. So this equation is going to equal 8. I solve my parenthesis here, 22x, 15 plus. I'm going to do this inside bracket operation first. So this is 14 times 2 here, which is equal to 28. Put a bracket here, and then a square bracket here. And then what I'm going to get is I'm going to do this next bracket, right? So this here is 8 times 22x here. I'm going to multiply that by 15 plus 28 here will equal 43. And then finally I have here, this is 8 plus, not 8 times here, sorry. Let me just fix that here. 8 plus all that. And then finally I can do 8 plus and then 22x times 43, right? So 22x times 43, which will give me some number here. And I'm going to use my calculator for 22x times 43. So 22 times 43 here would be 946. This is 946 and then x here. And that is the most we can do to simplify this equation. And I have 8 plus basically this term here. So this here is my answer. And as you can see, they got the same solution using bad math as well. So this solution here is correct. Good analysis. All right. Number 2. What is 0.5 as a fraction? So I want 0.5 as a fraction. So if I'm looking at these guys here, again, this here is a decimal, right? So this guy is here is a decimal. And in decimal, I care about 2 different things. Sorry, this is really bad to see. So it's a decimal, right? So in this case, I care about this here is are going to the whole part. It's the whole number. And this here will be the fraction part of my number, right? So in this case here, I have 0 as my whole number, so I don't have to worry about my whole number. So I can simply just erase this, and I just care about this fraction here. So 0.5 as a fraction would equal. So it's going to be something divided by something, right? It's going to be, I have a numerator and a denominator here. And in this case, because this is a decimal, this here is going to be in the tens place here, the tens digit here. And I only have one number in the tens digit here. So in this case here, because I only have one digit in the decimal, my denominator here is going to be a 10 for the tens place. And then my numerator is simply the decimal part, or the fraction part of my decimal, which is simply just 5. And so 0.5 as a fraction is 5 over 10, but then I can also reduce this guy, right? I can reduce this by simply dividing both sides by both the numerator and the denominator by the greatest common factor. In this case, this is a 5. This will also be a 5. So you get 1 over 2 here. And this here is going to be my answer for this problem. Half is the solution. So 0.5 equals 5 over 10, which equals 1/2. So the solution here is correct. Good analysis as well. Number 3. What is 58 inches in feet? (58 inches in feet). So again, these here we're both working in the imperial system, right? So this here, again, I don't have any meters or something like that. So I have a type of, this is in the imperial system. And these guys are measuring length here, right? So in order for us to do this, we're going to have to we need some conversions, right? So I know that 1 feet here, or 1 foot to be more grammatically correct, equals 12 inches. And knowing this conversion factor, what we can do is we can actually convert 58 inches, right? We can say that we have 58 inches when we started. So 58 inches, multiply that by, I want to multiply that by the conversion factor, right? So again, I have 1 foot or 1 feet equal, and I have 12 inches in a feet, right? And again, I want to convert to feet here. So this here is going to be my conversion factor. Again, these inches are going to cancel out. So I'm left with, my answer is going to have feet here. I'm doing 58 times 1 over 12, or you can think of this as 58 divided by 12 here, which will give me a value of 4.83. So, or you can say it's 4 and 5/6 feet, or you could say just approximately 4.83 feet. And this here is our answer for the solution. And as you can see, this one, they actually gave it to you also as well as in inches as well. So this is actually an even better answer, so 4.83. And what we can do with this is we can actually convert this into inches as well, right? So if we have, what we have here is we have 4 feet, 4.83 feet, but we can also take this 5/6 fraction part. 5/6 of the feet will equal basically 5/6 times our 12 inches. In this case here, this will give me 2, so 5 times 2 would be 10 actually. So in this case, it's actually not 8 inches. 8 inches would have been 3/4. So their solution here is not correct, actually. It's actually, this here is 10 inches. So you can also say that 58 inches is equal to 4 feet 10 inches here. So this solution is actually incorrect because the last part is wrong, but the math here is correct. So solution is correct except for the concluding statement. 58 inches equals 4 feet 10 inches. So I'm going to say here solution is incorrect just so they can fix this as well. Okay, that's number 3. Number 4 is asking us how many feet in half a mile. How many feet in half a mile? So again, this is we're working in the imperial system, and this is measuring length again, right? So what we have here is we have half a mile here. So we're starting with half a mile. Then we're multiply that by our conversion factor, right? So let me write out these conversion factors first before we start. So we have 1 mile is going to equal 1,760 yards. We know that 1 yard is equal to 3 feet. So I want to go from miles to feet here, right? So this here is my conversion factor. So I have half a mile. And multiply that by, I know that it's, in 1 mile, I know I have 1,760 yards in 1 mile. And then in 1 yard, I have 3 feet, right? So I have 3 feet per 1 yard here. And as you can see, these cancel out. Miles here cancel those out. Yards here cancel out. I'm left with feet, which is great, which is what I want here. And I'm simply just doing half times 1,760 times 3 here would give me my answer. So 0.5 times 1,760 times 3 here would get me my answer here, which is 2,640 feet. And this here is a solution. So therefore, we can say that half a mile equals 2,640 feet here. And this solution here is correct, I believe. Yes. So half a mile equals 2,640 feet. So this solution here is correct. It's good analysis as well. Next, number 5 is asking us, what is the cubed root of 1,000? So I want the cube root of 1,000. So when we talk about the cube root here, is I'm taking this cubed. This is a cubed root. So I have a little 3 here, the square root, and this is of 1,000 here. And in order for us to do this problem here, what we can do, we can basically do a prime factorization of 1,000 here. So how do we do this? So again, we're going to take this 1,000 number and we're going to divide it and keep dividing it by a prime factor. So we're going to use this concept of, again, prime factorization. And so if I have 1,000 here, I'm going to break this to 1,000 into root 2 times root of 500. And then I'm doing, again, I have another root 2 times, I'm breaking this 500 into root 2 times root 250. And then 250, I can break that down even further, 2 times root 125. And then this here, of root 125, I don't think it's divisible by 3, but it is divisible by 5, like all numbers that end in 5. So for root 2 times root 2 times root 2 times root 5. So if I divide 125 by 5 here, it's simply just 25 here, right? And then finally, I have, so it's going to equal root 2 times root 2 times root 2 times root 5. And all that root of 25 is simply just root 5 times root 5 here. So what I can see here is I have basically 2 times 2, or I have root 2 times root 2 times root 2, and root 5 times root times 5 times root 5 here, right? So I have all these guys here, and as you can see, this here is, I can write it out as kind of this of the prime factor. So you can say that these guys here, you can think of this as root 2 cubed, right? Because I have 3, I'm multiplying this times 3, and then I'll also have root 5 cubed, right? And this is going to equal, again, the cube root of 1,000 here. So what we can do here, of 1,000, because that's what we're solving for, we can actually, we can do a cube root of both sides here, right? So this is going to be, this here equals 1,000. We can take the cube root of both sides. So I can cube root this side, and then we cube root this side. This is going to eliminate these guys here, right? So again, this here will be eliminated. So I simply have, this would be 2 times 5, right? So let me just double check my math here. Let me just double check their math as well. So it's 2 cubed times 5 here. Yeah, so they're doing the prime factors as well. So they actually, instead of using the square roots, they actually used whatever, they actually broke this down into the prime factors of simply just 1,000 here. So they basically just erased all of these guys here, and they just simply did the prime factors here. So let me just redo that for you. Whoops. Oh, that was a 5. So basically, they're taking the prime factors here, and then I have 1,000 equals all of this stuff here, right? So I have 2 to the cubed times 5 to the cubed, and then if I cubed root both sides here, if I cubed root again this side and this side, I'm going to cancel these guys here, which will be 2 times 5 here, and then simply cube root of 1,000 here is 2 times 5, which is equal to 10 here. So therefore, 10 here is the answer, and again, 10 here is the answer as well. So the solution here is correct. I think I thought of this problem slightly differently, because I usually, cube roots aren't usually asked, but if they are, we simply just take the prime factors, and we do that. But I think I included the radicals here by accident, because I thought we were taking the square root. So the solution is correct. Solution is correct. Good analysis as well. Let's do, I believe I did this problem already in the last stream actually, so might have to just redo it again, that's okay. Maybe we have some repeats here. So we have how many ounces are in 500 ml. So in 500 ml we have, so what we're going to do again, we have, these guys are, we're in the metric system with 500 milliliters, and we want to convert it into the empirical system, right? And all of these guys measure volume. And we know that 1 ml here, our conversion factor is 0.033814 ounces, right? So if I want to convert this guy, I have 500 milliliters here. And then in 1 milliliter, I have 0.033814. So I have 0.033814 ounces. I want in the numerator for my units over 1 milliliter here. So again, these guys cancel out, mLs cancel out. So I'm going to get 500 times this guy here, which will give me my answer. So 500 times 0.033814 will give me 16.907 here. So therefore, 500 ml equals 16.907 ounces. So approximately 17, just under 17 here. So the solution here is correct. Again, they have 16.907 as well. Solution is correct. Good analysis. How many pints are in a quart? Number 7. We're speeding by these questions, by the way, which is great. I think a lot of these guys are actually really easy. How many pints are in a quart? Again, this here is the imperial system, and we're measuring volume. So again, we want to figure out how many pints are in a quart. So I'm going to write down my conversion factors. I have 1 gallon equals 4 quarts. 1 quart here equals 2 pints. And what you realize here, we can actually stop our kind of writing down our conversions because my answer lies already here. Right? 1 quart here equals 2 pints. So how many pints are in a quart? Well, there are 2 pints in 1 quart here. So therefore, you can say our answer here is simply just, therefore, there are 2 pints. Are 2 pints in 1 quart here. And this is our solution here. Again, there are 2 pints in 1 quart. The solution here is correct. That's number 7. Number 8 here. He's asking, how do you write 45% as a fraction? 45% as a fraction. So if I want to convert 45% to a fraction, again, I have this guy here is a percentage, right? So I have a percentage, and I want to convert this into a fraction. So this is a percentage. Convert it into a fraction. So in order for me to do that, all I'm going to have to do is simply just divide by 100, right? So I have 45% here. I'm going to multiply that by 1 over 100%. And this will give me, again, the percents here are going to cancel out. And I'm going to get, again, 45 at the top and 100 at the bottom here. And this here is my fraction. But with 45 over 100, again, as you can see, I can probably reduce. I'm taking the common factors of these guys. Greatest common factor in this case is 5 here. So this will equal 45 divided by 5 is simply just 9. And 100 divided by 5 here is 20. So this here is my answer. So therefore, we can write that 45%. 45% is 9 over 20. And this here is our correct answer. And as you can see, this here is also the correct answer. 9 over 20 is the correct answer here. So solution here is correct. Good analysis. That was number 8. Number 9, we're looking at what is the measure of PQR in a quadrilateral PQRS. So number 9 here. Number 9, yep. So I have some type of quadrilateral. I don't know if I should redraw this here. Yeah, maybe I will. I have a line here. Another line here. Line here. Okay, so I have some type of quadrilateral. This here is S, R, P, Q, and these sides are parallel, or SR is parallel to this, but these two sides are the same length here. So this is 115 here. And I want the angle of PQR. I want the angle of this guy over here, right? So if I want the angle over here, and I know that these two sides here are the same, so we can actually do something called an extension. So we can actually extend these lines here, and I'll see if I can draw this nicely here. We can extend this line because again, lines kind of have infinite length here. So we can extend this line. And as you can see, this line here is 180 degrees, right? So this here is, if I want to find the measure of this angle here, this theta is simply just 180 minus the interior angle, which is 115 degrees. And this here would be 65 degrees, right? So this theta would be here, this angle here would be 65 degrees. But it's asking us, our problem here is asking us what is this angle here, right? So knowing this here, 65 and 115 here, we can actually solve for these guys over here. So let's see what they did here. So again, they kind of extended this guy here as well, right? So they actually extended it into a Pythagorean theorem question. So this is another way of looking at it as well. You can actually you can draw kind of a right angle or make a right angle like so. And this here would be a right angle. This here would be 65 and this here would be 90. You can also do the exact same thing here. You can make a right angle as well. And then you can also use Pythagorean theorem to figure out this angle as well. So let's see what they wrote here. SP equals, so this is again, they did here Pythagorean theorem. So they want to solve for one of these sides here. So they're doing SO plus OP here. They want to solve for this side here. And as you can see, they did two Pythagorean theorems. So they did one on this guy here and one on this guy here. So but we know that here SP and, SR and PQ are parallel. So therefore SO and R equals RT, right? So these two lengths here are the same. So therefore we can say that SP and RQ have the same length. So these guys here have the same length. And we actually know that because of the dash here, right? So knowing that, then what we can do is, this is actually really, really complex as what they did here, but if you know basically the area, the intersecting angles, you can actually figure out that this is the same angle as this guy here. But this is a lot more math than needed to figure out this guy here. If you just know the sum of the interior angles, you could already solve for this guy here, because you know that this angle here is 115 as well, because both of these sides are the same. But I'm just going to check their math to see what they did here. So they did that. Okay, so this is correct, 1 and 2. So they did substitution. Therefore, SPO and RQT are congruent. Okay, so these guys are congruent, like we know before, because these two sides are, we know that side angle here are in play. So both of these guys are congruent, which is good. And they figure out my angle as well. 65 degrees is the angle here. So knowing that, then you can simply say 180 minus 65 is 115. So this is actually really, really, really complex as to how they did it. I personally don't like this method. It's actually a bit more convoluted here. So I'm going to say, so again, I solve for this angle here, right? 65 degrees. And because these guys here, I know that these guys here are the same here. So therefore, this angle here must also be 65 degrees. And therefore, I can solve for this theta here. So this theta, or actually, I'll make this angle alpha here. So angle alpha here is simply just 180 minus the 65 degrees. And this here is simply just 115. So this is going to prove that this angle here, PQR, is 115 degrees. So therefore, we can write that angle PQR equals 115 degrees here. So this here is a very, very convoluted solution for such a problem. Again, if you know the sum of the interior angles, you can very, very easily solve for this problem here. You don't need to use substitution in Pythagorean theorem. You're just extending the problem here. So solution is correct. Good analysis. Good analysis, however convoluted. That's not how you spell convoluted. Convoluted. If we know the sum of the interior angles, or if we know that the interior plus exterior angles equals 180 degrees, and we know that SP equals RQ, then the same angles must exist on the other side of the quadrilateral. Quadrilateral. There we go. So therefore you can say angle PQR equal to 115 degrees. So I'm going to say solution here is correct, but again, very, very convoluted way of solving this problem here. So this is number 9. Let's look at number 10. It says solve the system by elimination method, where you eliminate y. What is the resulting equation? So this is number 10. Again, lots of ways we can actually think of this problem here. In this case, we wanted to use elimination. If you were in a grade 10 class here, or kind of an algebra 1 class, you would definitely do elimination or substitution to figure this out. If you were thinking as a grade 10 here, I would definitely do elimination here. Again, it's already both in standard form, so you definitely use elimination. If you're in a higher level mathematics or university math here, you'd simply just use linear algebra. You would put this into a matrix and you would use Gaussian elimination to solve for this problem as well. So it depends on how you want to solve for it. In this case, I would probably use elimination because we simply have 2 equations and not 3 here. So it's a easier solve here. So we have 2x plus 3y minus 10 equals 0. We have 4x minus 3y minus 2 equals 0. And we want to eliminate this, right? So when we want to eliminate something, we want to make something equal to each other, right? So what we want to do first is, if we want to eliminate, we are going to subtract both of these guys here. And we want to be able to we want to eliminate a variable here. And in this case, I actually can't eliminate any of these variables here. I have to do something for us to change our equation here. So in order for us to do that first, I can see I have 3 here and I have minus 3, but 3 minus minus 3 would give us a 6 here. So what we want to do here is we want to be able to multiply some type of constant here to both of these guys, so that these guys would eliminate each other. In this case here, I'm going to multiply our entire equation by 2 here. I'm going to multiply our first equation here by 2. Oh, I want to eliminate y. Sorry. I want to eliminate y here. So if I want to eliminate y here, I want to multiply basically either I can multiply this guy by -1, or I can multiply this guy by -1, because I want this to be a positive 3 here. So maybe I'm going to multiply. I'll multiply the second equation by -1. So this changes, right? This would change my equation to, if I multiply everything by -1, I'm getting -4, positive 3, positive 2, right? And I'm simply using elimination here. So I multiplied both sides by -1. Again, 0 times -1 here is 0. And what I can do now is I can simply eliminate, right? So 3y here becomes 0y. 3 minus 3 here becomes 0. So that's what I want here. So these guys cancel out. And I have 2 minus 4. This is simply just 6x. And then minus 10 minus 2 would be minus 12 here, equals 0. And then now I can solve for my x value, right? So I have 6x minus 12 here. I can move 12 to the other side. So 6 here equals positive 12. And I can divide both sides by 6 to get x equals 2 here. So 2 here is my solution. And I simply, all I'm going to have to do is plug in into one of these equations. So I'm going to say that this guy here is 1. This guy here is 2. I'm going to sub into 1. I'll say sub x equal 2 into equation 1. And then I'm going to have 2x plus 3y minus 10 equals 0. I'm going to sub x here equals 2. So 2 times 2 plus 3y minus 10 equals 0. And then I can easily solve for this solution here. I'm going to have to isolate for y. So 2 times 2 here equals 4, plus 3y minus 10 equals 0. I can move 4 to the other side now. So I have 3y minus 10 equals -4. I can move the 10 to the other side as well. So I have 3y equals -4 plus 10 here. So -4 plus 10 is going to equal, again, this here is -4 plus 10, which will equal positive 6. And I can divide both sides by 3 here to get y here equals 2. So my solution to this problem would be 2 and 2, right? So the point of intersection, or the solution to this problem here, would be 2, 2. And this here is my solution here. So let me see what they did here. Just to eliminate, we must add 3y to the minus 3y in the bottom equation. Then we must do the same to the rest of the equation. This gives us, so I have negative 2x minus 4x minus 10 minus 2. So I have negative 2. So it says when you see two equations, just add / subtract them from the top to the bottom here. So this here again, I multiplied here by -1, so I got rid of this this negative number here. I'm just gonna see if x equals -4 is indeed a solution, because again, you could have in the systems of linear equation, you can actually have you can have an infinite amount of solutions here. So I believe that this here is actually can I not plot this? Try adding an equal sign to turn this into an equation. Okay. And then 4x minus 3y minus 2 equals 0 here. So this here, x equals 4 here. So if x equals -4 here, let's see, x equals -4, and there would be 6 here would give me a solution as well. So all of these guys, so this here is actually not my solution. My solution here is again 2 and 2, right? So this here is the point of intersection that I care about, 2 and 2, and that's what I solved through here. So in this case, this solution here is incorrect here because x equals 4 is not a solution. In this case, this system of linear equations is going to give us one solution. So this solution here is incorrect. Incorrect. So I will have 2 plus 3y minus 10 here equals 0, and I have 4x minus 3y minus 2 here equals 0. So I'm going to say here, in order to eliminate y from to eliminate y, we must multiply equation 2 by -1 to turn -3y into +3y. So I have 2x. I'm going to copy and paste this, sorry, just to correct their solutions here. So I'm going to have -4x plus 3y. And then minus 2 equals 0. Subtract both equations to get, and you get -6, or you get +6x. So I'm going to write a minus sign here to get 6x minus 12 equals 0, and therefore I have x here is going to equal 12, or sorry, 6x equals 12. And then finally I have x here is going to equal 2. And then what we can do is sub x equals 2 into equation 1. So we get 2x plus 3y. I'm going to copy and paste that, 2x plus 3y minus 10 equals 0. And we can say 2 times 2 plus 3y minus 10 here equals 0. 4 plus 3y minus 10 equals 0. So now I'm going to put 3y minus 10 equals -4. And then I'm going to have 3y here. Y equals -4 plus 10 here is 6. So therefore y here equals 2. So solution to this system of linear equations is 2, 2. So the solution here is incorrect. And finally, question 11. Question 11, I have, how do you write 0.25 in fraction form? So write 5 in fraction form. So again, I want to convert this guy here is a decimal into a fraction. So again, I have 0.25 here. So because I have no numbers before the decimal place, I can only focus on these guys here. So this here is my decimal part. This here is the tens digit. And this here is the hundredths digit, right? So therefore, my fraction is going to be something over 100, right? So I care about the last digit of the fraction here. So it's going to be over 100. or sorry, the denominator is going to be 100 because it's for the 100th place. And finally, the numerator is simply just whatever the decimal is, which is 25. And again, I can reduce both of these guys by the greatest common factor. In this case, it'd be 25. And this here would equal 1/4. So this here is my solution for this problem here. So 0.25 is equivalent to 25/100, but you can also reduce this even further to 1/4. So solution is correct. However, you can reduce 25/100 to 1/4 for to 1/4. Always reduce to the lowest terms. So that's going to be the question 11 for today. I'm going to see if I can load up some other problems, maybe some harder problems for us. Maybe we'll do about like maybe 2 more problems. We can do stuff from maybe grade 12, so senior level math, and then we'll kind of finish that off for today here. So let me load those up here. For us here. So I'm going to load 2 problems here. Let's load this problem. So this would be a kind of grade 12 problem. This would be also a grade 12 problem. So let's load these guys up as well. Let's load this up here. So this is again, this here would be a senior level math problem here now. This will be question 1. We'll finish off this video with these 2 problems here. So it says number 1 here says that, I guess this solution is definitely incomplete here because there's no, actually maybe I'll click this image to see if I can kind of open the image to see if this, to clarify things up here. So let me see if this works. There we go. Okay. So I want to find the value of the sum of arctan half plus arctan 1/3. It says you can use the trigonometric identity here. So this here's number 1. So I want to find the value of arctan half plus arctan 1/3. And then it says there's a hint here. It says here tan of x plus y equals tan x plus tan y over 1 minus tan x times tangent of y. So this is my hint here. And it says here it's A, B, C, or D, and none of the above. And this guy wrote C here, but did not provide an analysis here. So let's solve for this problem here. So I have arctan of half here. So what is arctangent of half here? And remember, arctan is simply just the inverse of our, it's the inverse of our primary trig ratios, right? So what we can do is we can simply say this is equal to tangent of -1, or the inverse tangent of 0.5. And then what we have here is, and this guy would be the tangent, or the inverse tangent of 1/3, right? So we can do that as well. So we could choose to do that. But then we're going to have this, it says here, the hint is we have to, you got to transform this into tangent x plus y here. And it gives us some sort of value here. So in order for us to do that, we're going to assume that this here is going to equal x, and this here will equal y here. And then in that way, what we can do is we can actually solve for something here. So I'm going to say let to x here. So I'm going to say let this guy here is equal to x. And this guy is going to equal to y. So I can, again, I can rewrite this as this is tangent -1 of half plus tangent -1, or the inverse tangent of 1/3 here, right? So if given this here, what I can do is I can actually input this into this this trig identity, right? So I can say the tangent. Sorry, the tangent. Oh, why is this being dumb? Refresh the board here. So I'm going to say tangent oh, I think is it still a line tool? Oh no, I'm good. Okay. So tangent of x plus y, which is simply just this guy here is going to equal this guy here, right? So it equals this identity here. So I can say if this here is my x and this here is my y, the tangent of x plus y is going to give me this, right? So I can say that it's going to give me the tangent of this here is, so it's a tangent, it's tan minus 1 here of half plus tangent, and the inverse tangent, negative 1 of 1 over 3 over 1 minus the product of these two guys, right? So tangent negative 1 half multiplied by the tangent negative 1 of 1 over 3 here. So this here will give us our solution here. And why do we care about this? Well, we care about this because tangent of the inverse of tan minus 1 of half plus tangent of negative 1 of 1 over 3. Well, this is simply just, I can cancel out these tangents here, right? These tangents here simply cancel out, right? So they're if I take the inverse of something and I take it, if I take the tangent of something and if I take the inverse tangent of something, it's going to revert, right? So this is why I care about this kind of formula here. So I would get the tangent of this, it will equal basically the sum of these two guys here. So what I have here would be this, right? I have this would equal, again, tangent and tangent here, they're going to cancel out. These tangents are going to cancel out as well. And then I have 1 minus times the tangent here, this here is going to cancel out, and this guy also cancels out as well. So I would get a value of, let me just see here. Let's see. If I assume these are x and y's, I can plug it into this equation here, this identity, and then let's see here. I want to find the value of the sum of these two numbers here. So let's see. This is going to equal, again, I don't know how I can get this pi here, pi over 2 here. So I might have, because this, again, these two guys cancel out, these two guys cancel out, these cancel out. So I have half times 1 over 3 over 1 minus half times 1 over 3, which does not give me some sort of pi here. So this would be, again, 1 over 6 divided by 1 minus 1 over 6 here, which is simply just 1 over 6 divided by 5 over 6, which is 1 over 6 times 6 over 5. These two cancel out, which is equal to 1 over 5 here. So it means that the tangent of all of these guys here is going to equal 1/5 of 1 over 5. And that's going to be expressed in this kind of fashion here. 1/5 is going to equal the tangent of x plus y. So I can say that the tangent of x plus y equals 1 over 5. And let's see. And I know that x here is, again, tan minus 1 of half plus tan negative 1 of 1/3 here. But this doesn't really make sense here because the tangent here, it's not kind of like distributive property where I can kind of do that, and to put tan and tan is going to be distributed between both ways here. So that's not correct here. So I might actually have to redo my problem because I don't think I did this problem correctly here. I don't think this is a good assumption to put this here as x and this here as y here. but let's see what I can do here. So let's see, because I am given this identity here as well, right? So let's see. Maybe I'll erase this first, and maybe I'm gonna set x here as to the half and not to arctan, because that might have thrown me off here. So give me a second. I'm not sure if I can complete two things now. I think I jumped the gun here by accident. Let me erase these guys here. So what if I did, so instead of doing this guy here, what if I did the half here was the x, the half here is the x here, and this here is the y. So again, I'm going to plug this into my my tangent, or what I can do here is I can have tangent of some theta here, right? So again, I can have this here would be so let's see. So if this here is x and this here is y, then I can say the tangent of x plus y is going to equal the tangent of half plus the plus the tangent of 1 over 3 here divided by 1 minus the tangent of half times the tangent of 1 over 3 here. And this here is equal to, let's see, this here is equal to 1. Because, again, tangent of, so this entire thing is equal to, actually, hold up. I think I was on the right track before in saying that these guys are equal to half. So again, I have half here plus 1/3 divided by 1 minus half times 1 over 3. And I believe this here, it gives me 1 here. So let me see, half plus 1 over 3 divided by 1 minus half, 1 minus half, half times 3 here. Half times 1 over 3 here. Yes, this will give me 1. So this here gives me 1. And what I can do now is I can do, so this here is between, so you can say that since each individual term theta 1 or x here, x and y here is between 0 and pi over 4, then the sum must be between 0 and pi over 2, right? So you can say that here, which means that this here is x plus y. Oh my gosh. Refresh the page again. This is x. Let me draw. I cannot draw right now. Okay. So I can say that x plus y really. Sorry, board's bugging out, sorry. I can say that x plus okay, there we go. X plus y is going to equal the arctan of 1, right? Because that's what we solve for. This is arctan of 1. So this is going to equal whatever tangent minus 1 here. So I can say this is simply the inverse tan of 1, which will give us pi over 4. So this solution here is our answer here. So this here is pi over 4, so the solution here is C. So the solution here is correct, but they didn't give us an analysis here as well. So let me just, I don't know if I can plug this into it. So we can say tan x plus y here is going to equal, I can put half plus 1 over 3 here. Put that in brackets, divided by, again, I have 1 minus, I have half times 1 over 3. So this here is going to equal 1. So therefore, see, x plus y will equal, so basically I can say that, I think I skipped a step here actually. Let me rephrase this. So because, I'm going to do this in blue here. So because tangent of x plus y here equals 1, then I can say the inverse would be tangent of negative 1, or I can say arctan of 1, right? Arctan of 1 here, which is tangent of negative 1. So x plus y equals this, and which would equal pi over 4 here. So this solution here is correct. I think I missed this step in terms of algebraically manipulating it. So that's my fault here. So therefore, tangent x plus y equals 1. So therefore, I can say x plus y here equals arctan of 1. And then finally, x plus y would equal pi over 4. Therefore, the answer is C. So the solution is correct, but there's no analysis that was given as well. Solution is correct. And I don't know if I can get to the last kind of question here because I only have 3 minutes here. So I'm just going to look at the solution to kind of help you out here. So I want the derivative of tangent x, right? Okay. Actually, this one I might be able to do in time here. So if I have f of x here is tangent of x, I can use my quotient identity to figure out what this is. So f of x here is equal, I know that tangent is equal to sine x over cos x. And then what I can do is I can do the f prime of x here. F prime of x here is going to equal, I'm going to equal the, is going to equal the cos x here, times the derivative of our sine here, which is going to be our, which is cos x, right? Derivative of sine x is cos x. So this here is, you could think of this as g of x, and this is h of x here. So I have, again, this is going to be h of x times g prime of x. And the derivative of sine here is cos. So I would say cos x again, minus our g of x, which is sine x, times the derivative of our cos of h of x here, which is cos x. So derivative of cos x here is negative sine x here, all over cos squared x, so hx squared here, so cos squared x. And this is our quotient rule for the derivative. And I can simply clean this up by saying that this here, these two combined would equal cos squared x, minus this here is sine squared x here, all over cos squared x. So or this would be plus cos squared x. So I can simply say that this here is going to equal cos squared x plus sine squared x is simply just, you can think of this as cos 2x, or you can think of this as, this here is simply just 1 divided by cos squared x here. Because again, these two guys kind of cancel out here. So remember, sine here, these two, basically we know that sine squared x plus cos squared x equals 1, right? So this is the Pythagorean identity. So we can say 1 over cos squared x. So this is equal to secant squared x. And this here, therefore, the derivative of tangent x here is secant squared x. So the solution here is correct. It's a good analysis as well. So that's going to be all the problems I have for today. It's currently 1 o'clock. Again, thank you so much for watching this video. Again, my name is Joey. I'm currently streaming from Monday to Friday. Monday, Wednesday, Fridays are math kind of sessions, and Tuesdays and Thursdays are chemistry sessions as well. Thank you so much for watching. Stay safe, stay healthy, and take care. Have a great day.